Hello everyone, this video we will be discussing about pointer arithmetic. Before we begin with that, let's look at some of the properties of a pointer. So here what I've done is I have an integer array, a string, an integer array, a character array, and a trusty old int a equal to 10. I have two pointers, one an integer pointer ptr, a character pointer s. And what I'm trying to do is I'm trying to print out the size occupied by each of these pointer variables. So both of them occupy 8 bytes. So, and we know that pointers can only store addresses. So this makes sense that they occupy 8 bytes. But if pointers only store addresses and they both, and each pointer type occupies the same amount of space, why do we actually talk, or why do we actually tell which data type it belongs to? So why are we declaring the data type of a pointer? So the data type of a pointer is necessary in two situations. So when we try to dereference a pointer, and also during pointer arithmetic. Let's look at why it is necessary when we are using when during dereferencing a pointer. So here what I did is I made the ptr point to a. So ptr is now storing the address of a, and I try to access the value at that memory location using my pointer. Now what this does is it'll go to the memory location and it'll read some amount of bytes, and then it'll print it to my console. How does the compiler know how many bytes it should read from that address? That is where the data type of the pointer comes into help. Since I have defined it as an integer data type, it'll go ahead and read 4 bytes. If it is a character pointer, then what it'll do is it'll go ahead and read 1 byte. So one of the places where the data type of a pointer becomes necessary is during dereferencing. Now let's look at what we mean by pointer arithmetic. Pointer arithmetic means as it sounds, wherein we do some arithmetic operations upon pointers. So adding two pointers doesn't make sense, but in case of arrays, and for most of the cases, pointer arithmetic is only makes sense when we are working with arrays. So we know that the name of the array corresponds to the address of the first element. So rewriting this makes complete sense. Again, adding of two addresses makes no sense. So when you add pointer ptr with s, this gives no meaningful value. But subtracting two addresses does give us the amount of space between those two pointers, right? So this can be effectively used to find out the index at which the pointer is present, or other such applications. So now what I can do is I can do pointer plus equal to 1. What this will effectively do is, let's see what it does actually. So star ptr and L. So just to recap what I did, ptr is now pointing to the array arr. I incremented the pointer by 1, and now I'm trying to print the value present at that pointer location, 1. So we see that effectively the pointer moved by 1 index and is now printing the value present at that index. What if I increase the pointer by 2? So it's now 2, meaning it has increased by 2 indexes, and now it is printing the value present at this index. But how does this make sense? What are we effectively doing? Pointer stores an address which will be a hexadecimal value. So let's say ptr and L. So how does adding 2 to this value make sense? Since we know that arrays actually occupy 4 bytes of space, so the effective distance between these two indices will be 4 bytes. Between these two indices will again be 4 bytes, and so on. So how does it make sense for us to add 2 to an address, and it's able to give us some value which we can predict? So even in such cases, the data type of the pointer comes into play. Since we know that ptr is of an integer data type, adding 2 to that ptr would actually mean adding 2 times the size of an integer effectively to the address stored at ptr. So if ptr has the address 0 and I add 2 to it, what it will actually do is it'll go to address 0000, and to that it'll add 2 times the size of an integer, which is 4 bytes, which will effectively be the memory location 8. So that's how the compiler actually computes when we actually add a when we add an integer literal to a pointer. Now we have a pointer which has been moved up by 2 places. What we can also do is we can do address of arr of 2. Oh no, we are just assigning it here. So we see that the value is 2. Now what I can do is, since ptr is storing the address of the second index, what happens if I subtract that address from the address of the 0th index, which is nothing but the name of the pointer. We see that we get an answer 2. Why is that? So as discussed before, ptr is effectively 2 indices ahead, so it will be pointing to this memory location. ARR will point to this memory location. The difference between those 2 memory locations is effectively 2 integer spaces, which is getting printed out. So this was about the subtraction arithmetic operation and the addition arithmetic operation, which we did by ptr plus equal to 1 or ptr plus plus and so on. Again, pointer arithmetic only makes sense when we are actually working with arrays. The data type of that pointer helps us in determining, or helps us in 2 operations, which is dereferencing the pointer and also during pointer arithmetic. We can perform mathematical operations of addition and subtraction on the pointer, but addition of 2 pointers or 2 addresses makes no sense. But addition of a pointer and an integer does make sense, and how the compiler interprets it is that it adds the integral amount of space occupied by the data type of that pointer to our pointer, and that effectively gives it a new address present in that array. Similar to addition, we also perform subtraction operations in order to find the differences, or in order to find an index at which the pointer is pointing to for that array. So this was all about pointer arithmetic. Thank you.